I'll turn this podcast right around. Hey everybody, and welcome to episode 38 of the iPhreaks show. This week on our panel we have Jaim Zuber.
It's 10 below, my car won't start, and I'm not even mad.
Ben Sherman.
It's 35 degrees, and I'm also cold, but not quite as cold.
Andrew Manton.
25 in Salt Lake City.
I'm Charles Max Wood from DevChat.tv. Last week it was like 70-something degrees where I was at, so very nice. So this week we're going to be talking to Andrew. He's kind of our guest, I guess. We're going to be talking about OS X programming. And, you know, it's kind of interesting after learning some of the techniques and tools for building things for iOS. I haven't really looked at what's different with OS X. Do you want to kind of get us started on some of the things that we have to know or do differently?
Sure. Well, I think the first thing to know is that iOS and OS X are sort of siblings, or you might even say that iOS is like OS X's kid, but iOS was obviously Apple's chance to sort of do over things that they wanted to do differently, without the whole legacy baggage that kept them from doing that on OS X. So in many ways, iOS is the more modern of the two. I wouldn't say operating systems, but the APIs are certainly more modern in a lot of places. So there are things on OS X that are just more difficult, and if you're coming from an iOS background, you're sometimes left thinking, man, if I were on iOS, this would be super easy, but it's not so easy on OS X. Fortunately, there are also a few places where the opposite is true, and OS X still makes things easier than they are on iOS. And I'm not exactly sure where to start, because there are quite a few differences.
How about just the, like maybe the Hello World example? Like the first thing I noticed when I create a new Mac app is I'm used to just getting a view controller for free, and that is kind of absent. You've got a nib, and that gives you a main window, but there's really nothing else it gives you, right?
Right. Well, that's actually a great place to start. So on iOS, if you've done iOS programming, you know that UIViewController is sort of like the main class almost in iOS. Every single time you have a view on screen, it has a UIViewController controlling it. On OS X, there is actually an NSViewController class, but that was introduced in 10.5, so relatively recently in the history of OS X. And what that means is that you can write an entire app without using NSViewController. It's not sort of the vital class that UIViewController is on iOS. And that sort of gives you a lot more flexibility in terms of how you structure your application. But these days, I've actually started using NSViewController more like UIViewController is used on iOS. So I do tend to have an NSViewController, not for every window on screen, but for every sort of logically grouped major view in my window. And NSViewController does do the same sort of thing as UIViewController, but it's not nearly as full-featured. So it really it knows how to load a view up from a nib and do the memory management of outlets, and that's kind of about it. It doesn't have all of the convenience methods that you can override for like view. Even it doesn't even have view did load, but like view did appear, and obviously rotation methods don't apply. Another thing to know about NSViewController is that it's not in the responder chain. So unlike UIViewController, you can't implement responder chain or methods that you expect to just be called by the responder chain being blocked there.
So if you wanted to have like a, say a blue box that you, I don't know if that would just itself be an NSView or whatever, and then you click and drag on it, you'd actually have to put the mouse handling code in the view and decide correct. To bubble it up to the controller via some sort of event or delegate system.
Yeah, that's exactly right. So in NSView, you have the same kind of event handling methods you would find in UIView. Of course, there are mouse and keyboard handling methods that are more important than the touch handling methods, although there are also touch handling methods because we have these multi-touch trackpads and such on modern Macs. But you're exactly right. So those have to be implemented in NSView. And then if you want a responsibility for those to be taken over by the controller, it's completely up to you to figure out how you want to pass those up. And typically I do that by making an NSViewController the delegate of its view. You know, and you create a custom view or a custom delegate protocol to pass those back up and do whatever it is that needs to be done with them.
I think that's not necessarily a bad thing. I mean, I think it was kind of a point of confusion when I was learning iOS that view controllers would just magically get touch events.
Right, and you have to, I mean, it's not magic, of course, but I'm not sure it makes a lot of sense conceptually unless you understand the whole responder chain, because the touch, of course, is happening conceptually on the view, on the screen, right? And but that's the way it's always been on OS X. And in fact, like I said earlier, you don't actually have to use NSViewController at all if you don't want to. And the sort of the old way things were done was to have views handle all of their touch handling logic and user interface stuff all in the NSView subclass. You'll still find a lot of code that's written that way. And in fact, like you said, if you just create a basic Mac app from the Xcode template, you don't get a view controller at all. And actually, that kind of annoys me because they stuff everything into the app delegate, which we've all heard talked about before, even on iOS, but it kind of encourages especially new people to fill up their app delegate with all of their program logic. And factoring all that out is completely up to you. The template doesn't even sort of guide you toward a better approach. So I think a discussion of NSViewController leads to another class that is pretty important on OS X that doesn't really have an exact counterpart on iOS, but that's NSWindowController. And I guess in some ways NSWindowController is sort of more like UIViewController than NSViewController is like UIViewController. And that's because typically, again, you don't actually have to do it this way, but it is fairly common because NSWindowController has been around for a long time. But you'll typically have an NSWindowController that controls each window on the screen. And a window on the screen is kind of like UI window, except that you can have as many as you want. Your application is not limited to one window at a time. But NSWindowController handles loading from a nib and memory management and has like window did load that you can override and has methods to close the window and to show the window and that kind of thing. So that actually becomes a good place to put normal controller kinds of code that are relevant to an entire window.
And so a window would be composed of views. And would you have the same sort of window controller containing a child NSViewController?
That's up to you again, because there's a lot more flexibility, but that's typically how I do it. So typically I'll have an NSWindowController and then it has a single content view that contains all the subviews for that window. And I generally actually break, depending on the application, of course, but if it's a fairly complex application, I'll often break the main Windows UI up into multiple NSViewController managed views. OS X does not have the parent-child view controller stuff that iOS has, so if you're I like that paradigm, but you have to do that yourself. So it's your job to manage adding the child view controller managed views to your main content view and removing them as appropriate and all that. You don't have any of that parent-child hierarchy management stuff built in for free. Got it.
What about, I know that NS views are not layer backed like UI views are. And, in iPhone, you can, change which layer class you are, and you can just assume that there's always a layer. How is that different in Mac programming?
So by default, an NS view is not layer backed at all. Unlike a UI view where they always have a layer backing them and doing their drawing. NS view by default does not have a layer, but you do have the option to make an NS view layer backed. And there's also a second kind of layered view that is not on iOS at all, and that's called a layer hosting view. I can talk about that in a minute, but a layer backed NS view is a lot like a UI view in that it always has a layer, and you can change the class of that layer and set the same sorts of properties on the layer that you would set on UI view. Of course, the methods to do that are not on NS view, so you have to access the layer directly. There's no set background color on an NS view, for example. But otherwise, that's fairly similar. It is important to keep in mind, though, that core animation was tacked onto iOS or onto OS X in 10.5. Unlike iOS, where it was there from the very beginning, and a lot of the very foundation of a lot of the UIKit stuff depends on core animation. That's not really true in AppKit, so it's a little more of an afterthought, not quite as extensively used as you would use it on iOS.
Another thing I remember reading about, I started off learning Objective-C through Aaron Hillegass's Cocoa Programming for Mac OS X, I think 3rd edition book, which was really excellent. But at some point, I I realized I was learning, or I sort of need to bridge off that book and start practicing iOS because the two are so different. And I remember the biggest difference that I first noticed was the book used bindings a lot. And I don't know if this is just my experience with doing this sort of thing with Visual Studio in the past, and my utter hatred of sort of magical connections that make forms over data really easy, but complicated apps a lot harder. And so I wasn't sure if anybody really used bindings, and I was kind of glad that they weren't on iOS because it meant that things were a little bit more explicit. So what I mean by that is if you have something like I don't know if you have a converter application that converts like units from one format to another. So you have like, degrees Fahrenheit to degrees Celsius. And when you change one text box that it automatically changes the other one. Things like that. Is that something that people use?
Right. Well, I can kind of only speak for myself, but I really like bindings. I've been using them since I started doing OS 10 programming when 10.3 was the current version, and that was also the version that introduced bindings. So they've always been around, but they were sort of new when I started, and I really like them. I use them quite extensively. I know there are people who don't like them for various reasons, but they are certainly one of those things that has a learning curve associated with them, like core data or something. But to me, the effort to learn them pays off in much faster development in certain cases. I mean, you're right that if you try to do anything too crazy, you end up hitting into their limitations. But something like a unit converter, like you described, is certainly possible with bindings, and I might very well do that with bindings if I were doing that.
One of the things that I don't like about that type of system, not that I necessarily don't like, but certainly is a drawback, is when you're debugging something that is going wrong, you can't necessarily put a breakpoint on that. Or maybe you can, but if there's no code to look at, it's very difficult to see like what is actually happening in here. And it may very well be that you're just opening up a nib and you accidentally fat finger a checkbox somewhere or one of the key paths somewhere, and just stuff doesn't work. It just seems like that is a less favorable debugging scenario than like a compile error, for instance, or something where you can actually set a breakpoint and be like, well, what is the value at this point?
Yeah, I think you're right. I think maybe for the benefit of our listeners, we should explain what bindings is, because if you've never done OS 10 programming, there's a good chance you haven't hit into them. The whole idea with bindings is that you can have something in your model and something in your view, and so say you have a string property in your model class and you have a text box in your view, and you just want anytime somebody types something into the text box, that gets set in the string property, and anytime the string property changes, you want to update the text box's contents. In iOS, everybody kind of knows how to do that. It's not that complicated, but you do have to write some code in your controller to take updates from the property and send them to the text box and vice versa. With bindings, you can set that entire thing up in Interface Builder, and you don't have to write any controller code at all. In fact, you don't have to write any code. If you have this string property in this text box, you can hook them up with bindings, and updates to one or the other will be reflected in the other, like magically. I think it's important to know when you're dealing with bindings that they're actually not magic, even though they seem that way. They're built on top of key value observing and key value coding, just like you'd expect. And in fact, those technologies were introduced when bindings came out to support bindings. And I think you're right, though, that it can be more difficult to debug when you don't have code to look at that you wrote. But on the other hand, bindings, as long as you understand that it's really not much more complicated than when you set up a binding, a KVO observance is being set up. If you look at the error messages you get out of bindings and know that, you can often track the problem down fairly quickly. Because a lot of times the problem is like you mistyped the property name, and so you're trying to set a property that doesn't exist on the model object or something, and you'll get an error message that tells you pretty clearly that that's what's going on. So with a little bit of experience, I actually think debugging is usually not that big of a deal. There are, of course, trickier cases, and you can get part of the way toward debugging those by doing things like creating a custom getter for your property or a custom setter and overriding that and seeing what when that's being called or what's being passed into your setter, because those property methods do get called by the bindings machinery.
So what are some of the methods used for navigation throughout the application? Do you have something like a navigation controller?
Well, that's another good Another good question. No, there are a lot of those built-in UIViewController subclasses that are part of iOS that are used really heavily for creating your application's user interface structure don't exist on OS X. But there are some other ones or some counterparts that do exist. For example, you do have an NSTabView, which sort of serves the same function as a UITabViewController. It just has a bunch of child views that it can switch in and out with a tab control at the top, or you can make the tab control invisible and do that programmatically. That's actually sort of a big one for if you want to do other kinds of navigation, like if you wanted to mimic iOS's navigation controller, you would have to write that yourself or find a project on GitHub. There's nothing built in quite like that. There are a lot of the other kinds of, there's an NSTableView, which is broadly similar to UITableView, although it's actually quite a bit more sophisticated in certain ways. And then NSScrollView is like UIScrollView. It's hard to rattle them off the top of my head, but there are a number of those kind of classes that have pretty close counterparts, and the APIs are actually fairly similar. Like if you've worked with UITableView a lot, you won't be shocked to see how NSTableView works.
Now, I've heard that NSTableView creates cells like UITableView does, but these are laid out like a grid, correct?
Yeah, that's true. So NSTableView doesn't just have rows, it also has columns, and those columns are optionally reorderable, and you can sort by them and all of that. So that's why I say in some ways it's more powerful. One more thing to mention about NSTableView that will sort of lead us into another discussion about one of the big differences between iOS and OS X is that there are actually two kinds of NSTableView. There are cell-based NSTableViews and view-based NSTableViews. And cell-based NSTableViews, which are the original kind that have been around forever, those use an NSCell to draw their contents. There's not a separate view for each row and column like you would expect if you were coming from iOS. And then there's a view-based NSTableView, which was introduced in 10.7. And that does use NSViews, or they're actually NSTableCellView instances, and there's one per row, and they're handled. There's a queue, just like on UITableView, where when they go off screen, they're taken out of the view hierarchy and put in this reuse queue. And anyway, it works very similarly to UITableView if you're using a view-based NSTableView.
When did that get introduced? Because I remember reading about the whole conundrum of cells aren't views, and it's kind of a pain in the neck.
The view-based NSTableViews came out with Lion in 2011, so they're actually still reasonably new. And with the slower adoption rates of OS X updates, there's still a fair amount of code out there that targets 10.6. But that's actually kind of an important thing to note, and that is that NSTableView got this view-based table view to get rid of its use of NSCells because they're kind of annoying. But NSCell is still used pretty heavily in a lot of other places in OS X. So, for example, NSButton it uses an NSButton cell, which is an NSCell subclass, to draw itself. And if you're coming from iOS and you're used to making a custom button super easily like you can on iOS, you're in for kind of a bit of pain when you try to do that on OS X, because to create a custom button on OS X, you actually have to subclass NSButton and NSButton cell and override the drawing methods, and it's a little bit of a pain. And I think especially when you've never seen NSCell before, it's kind of hard to figure out what the thing's for and why it's there, and why not just have NSButtons be regular views that draw themselves. Anyway, NSCell is kind of a thing that a lot of Mac programmers will complain about a little bit.
I know auto layout was available on OS X long before it was, or I guess maybe a year before it was on iOS. Is that something that you take advantage of as well?
Actually, I have to admit that I've started like the last 5 Mac projects I've worked on using auto layout, and the problems that were in Interface Builder with using auto layout just annoyed me too much, and I ended up turning it off. But as with iOS, they improved that a lot in Xcode 5, so for the next project I start, I do plan to use it. But it's essentially identical to iOS. There's really not any major differences. I think it's a good thing. Everybody's heard about the problems that existed with using auto layout in Interface Builder and how frustrating of an experience that was before Xcode 5, so that's why I haven't used it.
So Andrew, help us get a little bearing about kind of the ecosystem for kind of developing on Mac. So we're talking Cocoa, right?
Absolutely.
Cocoa libraries?
Yep.
I know I've talked to a lot of people that have been doing Mac development for for decades, and a lot of it, what they're doing is like C++. Like, what are some older frameworks that people might run into?
Well, I'll get a little bit out of my depth here because I'm definitely a Cocoa programmer, but I think the biggest one to know about is that when OS X first came out and they needed to maintain compatibility with these code bases people had that were for the classic Mac OS, and so they created a thing called Carbon, which is I believe it's actually just a pure C API that could be used to quickly and easily port apps over from OS 9 to OS 10 and still maintain compatibility with OS 9. And Carbon sort of lives on, and it's getting less and less important, but it's still not unheard of to run into some API that's not really available in Cocoa and that you end up having to drop down into Carbon to use. But typically those are really small. I mean, you might write like 5 lines of code that use a Carbon API, and in my experience, it's always because I'm running into a problem and I find a Stack Overflow answer or something that tells me to do that. I don't know Carbon well enough to find those solutions myself. So it's really not something that you have to worry about a whole lot anymore. And Carbon is still around, but it's deprecated essentially. They never made it 64-bit compatible, which does not mean you can't write 64-bit apps that use little snippets of Carbon, but you can't write an entire Carbon app that's 64-bit. And other than that, I think you're not likely to run into a lot of stuff that's unfamiliar. Core Foundation is around, of course, and that's a C API, but the same is true on iOS. So you're not really any more likely to use Core Foundation on OS X than on iOS, and it has exactly the same APIs as it does on iOS.
Okay. Now, I had heard that kind of Carbon was not supported with the newest version of OS X. Is that the kind of the big thing? You can't do a lot of it, but there's little parts that are still supported?
Yeah, I can't really say exactly the whole scope of what's there and what works and what doesn't anymore, but I know there are parts of Carbon that are still around and still used in a lot of apps and definitely still work. I think one thing that kind of points to whether Carbon should be used or not is if you try to go looking for documentation for Carbon, it's actually really quite hard to find. Like if I wanted to learn for some crazy reason how to write a whole app in Carbon, I'm not even sure where I would start. I'd probably go install OS 10.1 or something and play around on that. So it's really not something to worry about.
Okay, so the Objective-C Cocoa stuff, that started with OS X.
Yeah, well, that's actually interesting. I don't know how many people are interested in this kind of thing, but I find the whole history, well, I find the history of things I use interesting in general, but Objective-C actually started a long, long time ago in computer terms, back in the early 80s and early to mid 80s, and Next adopted it, and that was Steve Jobs' company after he was forced out of Apple. And when Apple bought Next and decided to make their next operating system based on NextStep, they got Objective-C that way. So Objective-C and the Cocoa frameworks actually have a 25-year history. The first version, or the first Next machines came out in 1988, I think, is when NextStep came out. So, we're coming up on 26 years of those APIs, and they've changed a lot and matured even before Apple got them, but some of the fundamentals came from that long ago. And so that kind of helps explain why there are some of these legacy things like NSCell, for example, that really don't make sense now, or we've figured out better ways to do them, but in the next days they made sense for one reason or another. And often that can be explained by a Next machine might be 25 megahertz with 16 megs of RAM or something. And so performance was a huge bottleneck, even compared to the first iPhone. But these machines were really slow.
I remember reading a discussion about how terrible it would be for performance if we had a 10 by 10 table view and we had to create 100 views. Like, we're never going to be able to do that. So,
yeah, well, that's exactly why NSCell exists. So that is completely an optimization so that you could draw what conceptually were a lot of views on screen without hitting into a huge performance bottleneck. So when you're using when NSCell is used, especially like in a NSTableView, there's only one NSCell that draws the entire table view's contents. So you're not having to create a NSView, which is relatively heavy, and add that to the view hierarchy and draw it. And NSCell is a lightweight, quite simple class.
Okay, so the NS classes, those come way back from NextStep and introduced into kind of the Apple world in OS X. Is that
Yeah, that's absolutely right. So
Okay.
NS is abbreviation for next step.
So like the next step developers were like, hey, we know what's going on here. And the Apple developers were like, what is this madness?
Yeah, absolutely.
I thought it stood for new shiny.
Yeah, right. No, it's the opposite. It's old. Yeah, you're right. And there are some of those next step guys that are still kind of around. Like Will Shipley comes to mind. So he's still a pretty prominent developer in the Mac and iOS, although he's still mostly a Mac developer, but in the community. And he started all the way back in like the early 90s on Next and wrote some software that really was successful. And Omni Group, which is a company that he co-founded, they were Next developers that came over and started doing Mac software after transition. But they've been around doing it for a long, long time. And even Keynote. So Keynote is, I can't remember the name of the app, but Keynote really is a evolution of an app that started out as a Next app.
So I have maybe a sort of a tutorial type question. There's apps that I've seen like that are highly, highly customized, and then there are apps that sort of take the traditional OS X look and feel. One app that comes to mind is the Hit List. Have you ever played with this app?
No, I don't think so.
It's at potionfactory.com, and I really, really love this app. It's similar to Things. It's a to-do list manager, but it just has it just has such an attention to detail. I really, really like it. One of the things it does is it has this kind of, and this is pretty standard nowadays, but it has like the left hand, I don't know what you call it, like a tree view.
Mm-hmm.
And then there's no actual slider. There's just a line in between the two, like the main content pane and then like the left sidebar.
Mm-hmm.
I'm wondering how much of this type of application is custom. Like, is it starting from scratch, or can you take like I don't even know what you call it, like UI splitter or something, where you have some notion of custom drawing? You know what I'm saying? Like, I don't know if my question is clear. I'm just wondering, like, how would you build something like this, or like Things, if you're more familiar with that app?
Yeah, so I pulled up a screenshot of the Hit List, and I haven't seen this app, but the Potion Factory has been around for a long time, and I know about them. They're a great company. Anyway, looking at this screenshot, so over on the left, you called it a tree view, I think, and that's actually called an outline view in Cocoa terms, but there is actually a built-in class that does that, and just by the look of this, it's not heavily customized. That's pretty much, what you see here is pretty much just available with that built-in class. So NSOutlineView is actually a subclass of NSTableView, and it has a very similar API, but the difference is that it lets you have a hierarchy with collapsible folders and that sort of thing. And it also does not have multiple columns. It might be possible to have multiple columns. I'm not sure. I've never actually tried that. But anyway, so that part is all basically built in. And then as far as the splitter goes, that's also a built-in class called NSSplitView. So the part of the UI that you talked about is not custom. You don't really have to write a lot of custom code. You can get pretty much what you see there with just the standard built-in stuff. Looking at the app, there are some things in here that are definitely custom code, like the tabs up at the top. There's certainly no fancy tab view like that. There is an NSTabView, but it won't draw tabs that look like that. So you're certainly going to be doing a custom control for those.
So would you be starting with NSTabView and then like taking over drawing, or would you end up just writing it yourself? Well, I mean, these tabs act kind of like Chrome. You can drag them. So I'm guessing that's just its own control.
Yeah, absolutely. NSTabView is actually pretty limited, and it actually brings up an experience that I had, which is that the app that Mixed In Key just launched a couple weeks ago, its sort of main UI is some tabs, and we made a custom tab bar at the top that doesn't look like the built-in one, and that turned out to be, it's not difficult, but it's a lot of custom code, and if you wanted to do any of the fancy stuff like dragging tabs and being able to create new windows and reordering them, NSTabView does not even sort of get you on the way to that. So you really would be just writing your own. And it's actually something we're thinking about doing for the next version, is writing completely our own core animation-based tab view that can do custom transition animations and all that kind of stuff, just because the built-in one is actually quite limited. Of course, as with iOS, you look around on GitHub and Cocoa controls and see if you can find something somebody else has done that's good. And oftentimes you can. but maybe not as often as with iOS because there just really aren't as many Mac developers out there as there are iOS developers these days.
Right.
All right. Well, are there any other differences or gotchas to writing Mac apps that we haven't discussed that somebody who's familiar with iOS would run into?
I think we've actually covered a lot of the biggest things. I think maybe something that we didn't mention that is not really a difference in the APIs, but it's a difference in mindset is that you should, when you're writing a Mac app, you should keep in mind that iOS has always been touch-driven for very good reasons, and OS X is not touch-driven, it's mouse-driven, and always has been, and you should keep those kind of differences in mind. And when you design say you want to make a Mac version of an app you already have on iOS, unless there's a really good reason or it really lends itself well, you really ought to rethink the UI when you do an OS X version and support the kinds of interactions that people are used to on a Mac instead of just directly porting your UI over. Because the reason people use Macs when iOS is still around is because there are things that are still easier on a Mac with a mouse and keyboard, and you want to make it so your app takes advantage of that. You can make things smaller. You can make controls smaller than you can on iOS since you've got a more precise input device. You can put a lot more on the screen at one time. And then, of course, I think it's really quite nice in a lot of ways that OS X runs on machines that are still much faster than the typical iOS device. So you can get away with really CPU or GPU intensive things that still are a little difficult on iOS. So I work on audio apps, and it's still true that for the CPU limited stuff that we do regarding audio, it's just way easier for us to get that to work well on a Mac than on iOS, which is nice, but take advantage of that.
Yeah, developing for keyboard and mouse, it's becoming a dying art. It's not yet, but it's on its way. Very specialized apps are doing it. Kids are coming up and having no idea why they can't touch your desktop screen and move stuff.
Yeah,
that's true.
Why?
When you think about like the minimum level of dexterity you would need in your fingers to operate a mouse and keyboard, kids probably don't get interested in computers until probably 3 or 4 years old. Because like watching a 2-year-old try and use a mouse, it's tough. But my kids are 4 now. They've been using an iPad since they were like under a year old. My son was able to figure out how to unlock the iPhone at about 11 months. And to me, that's amazing. Like, he's never known a non-touch interface. And so when he gets on the computer, it's just a little bit foreign to him. It's almost like looking at like a telephone with a cord these days, or a phone booth.
Or landline interface,
Yeah. Well, he sees that on my screen all the time, so that's not quite so foreign, but yeah. But yeah, I mean, to me, it is kind of amazing. And the other thing that, probably keeps me on iOS more than anything else, and this is true of iPad as well, is that all of a sudden you have like way more choices and way more things to do and way more rope to hang yourself with. I know what good Mac apps look like, but I don't think I'm good at creating them, or at least in my head, just because there's so many things you could do, and you could, the way you lay things out, you have this ultimate flexibility, but unless you have like a clear picture in your mind, or if you have maybe a solid designer who knows what they're doing, to me, it's so much more difficult to design for than a phone that's 320 points wide. There are only 4 places for buttons. So if you have 6 buttons in mind, you got to start thinking of better ideas. And those constraints I find are comfortable for me because it allows me to, try to simplify in order to fit in that sort of screen real estate that we have.
I think you're right. And there's also a lot more heavily enforced UI paradigms on iOS. So, a table view and navigation views and those things are so much more enforced by the frameworks that it's easier to figure out, well, I basically know how this application is going to look and it fits into these paradigms and I know how to do that. And it's true that you have a lot more to come up with on your own on OS X. But I like the extra flexibility. Maybe it's just because I started as a Mac developer before iOS and still do more Mac development than iOS development, but I feel much less limited when I'm developing for OS X.
Yeah, if you get extra pixels, put a button in there. And if you run out, just load up the menu,
Yeah, absolutely. And I can add keyboard shortcuts and, But you got to be careful with that because you still want to, some of the same considerations that you would have developing on any platform, but you need to not go overboard.
Yeah, you can tell applications that have been around for 20 years and haven't gotten a real redesign.
Mm-hmm.
Yeah, absolutely.
Yep. Well, I hate to cut this off, but I know that some of us have some scheduling constraints, so I'm going to push us over into the picks. Ben, do you want to start us off with the picks?
So my picks are, the first one is called Mastering Modern Payments. It's an ebook. It's really short, and it covers how to do Stripe integration for normal, like Stripe stores, like single checkout forms, as well as subscriptions. And I've already done this twice, and I still was able to pick up a few tidbits of things that I should be handling. And anyway, it's a good read, worth the $30, $40 or whatever I paid for it. So that's my first pick. My second one is a fiction book. I'm trying to read more fiction. I'm just really slow at it. My mind tends to wander. So I'm forcing myself to read more fiction. The first one I got through this past couple of months was The Doomsday Key by James Rollins. So if you're into sort of fiction or sort of problem solving in the context of historical fact, I don't know what the genre I'm actually looking for. Historical fiction, maybe. Sort of like maybe Da Vinci Code style books. This was pretty good in that style. And the last one is a video I just watched on. It was more about game development, but this guy was talking about game feel. And it was two things. One, it was a really good presentation in how little tiny details make a game feel so much more playable and fun and enjoyable. And I think the same concepts can be applied to app development. But the other thing I liked about his presentation is there were no slides. His slides, so to speak, were actually like playable versions of his game. And so he just advanced to the next sort of evolution of what he added to the game. And he was just playing the game the entire time and advancing it and saying, okay, now I'm adding a little bit of camera lag. So it feels like the camera's, dragging behind the player and all that. So anyway, really, really good presentation. I will link all of those in the show notes.
Awesome. Jaim, what are your picks?
Okay, last week we talked about MVC and how we kind of communicate between kind of controller and model. And I didn't know it at the time, but objc-run.io has a really good article on the topic. So you can check out communication patterns. It goes over kind of the different methods you can have any two objects talk to each other, KVO, notifications, delegation, blocks. And if you can't think for yourself, but you can follow a flow chart, it's got you covered. So if you want to know which one to do, it's got you covered. So check out the communication patterns in issue 7 of Objective-C.io. My second pick, you've heard about the land shark, right? Don't open the door for the land shark.
The lager?
Well, don't drink that lager either. Stay away from the land shark. But a couple days ago, the snow shark started kind of blowing up the Twitter feed in Minnesota, and I thought, someone made a little snow sculpture of a shark. When I didn't realize it was 15 feet tall, and it was done by a group of high school kids. So I thought it was pretty cool. We have the snow shark. So I'll send a link to that, but check it out. Those are my picks.
Awesome. Andrew, what are your picks?
My picks are kind of themed around our topic today. So, my first pick is FastSpring. And FastSpring is a payment processor, for digital goods, but they're used by a lot of Mac developers to sell their apps outside the Mac App Store. And, I use them, and I've used them for, 2 years now, and, having switched from my own solution that was based on, it was a PayPal driven solution, but they do a really good job. I've been very impressed with them in terms of customer support and the experience of buying something using one of their websites. And so definitely recommend it if you want to sell your own app outside the Mac App Store. And then my next pick is just a little script that was released this week on GitHub, and it's called Objc-run, Objective-C-run. And this is just a small shell script, but what it does is lets you run an Objective-C.m file with a program in it as if it were sort of like a regular scripting language script on your command line. So Objective-C is the language I work in the most, and it's nice to be able to sometimes write just a little utility that will do something or other that some people might write a Python script or a shell script or something for, but I feel comfortable doing that in Objective-C, and this lets you run your Objective-C file as if it were a script. And then last is, I actually gave a presentation about this topic we had today about macOS 10 for people who are coming from iOS at Cocoa Slopes, which was a conference we had here in Utah a few months back. And my slides and also some example code, particularly related to bindings, are on GitHub, so you can check those out. The slides have a lot of presenter notes, so make sure you look at the presenter notes if you're going to look at those. A lot of the information that I gave is actually in the presenter notes. And those are my picks.
Awesome. My picks are really simple. The last week I was in Disneyland, so I'm going to pick Disneyland, and I went to New Media Expo, and I'm going to pick New Media Expo. And I'll just put links in the show notes, and you can go check those out if you don't know what they are. And other than that, I guess we're done with the show. So thanks for listening. Hope you have a terrific new year, and we'll catch y'all next week.
All right, I gotta go jumpstart my car.
Good luck.
Stay warm.